So here, let's do exercise 3.1, where we have our r, which is equals to vector 6,706, 4,025, and then 3,490, all in kilometers. And then we have our v vector, which is equals to negative 3.7817, negative 6.0146, 1.1418. Okay. Now I'm asked to find the 6 classical orbital elements, which are going to be A, E, I, Ran, Omega, or omega perigee, and I guess the last one should be just the E vector. Oh no, sorry, of course, the true anomaly. Okay, so now in order to do this, how do I find, well, starting from A, how do I find A? Well, I have R and V in vector form, but I can find their magnitudes, so a magnitude of R and magnitude of V. And then I know that zeta, which is the energy, specific energy, is equals to V squared divided by 2 minus mu over R. But it's also equals to negative mu over 2A. So I can rewrite this to be A is equals to, actually, let me not skip too many steps. So I have 2A on this side that multiplies everything on that side. So we have here negative mu that multiplies dv squared divided by 2 minus mu over r. And then I just divide everything by 2 here. So this is my A. I can code it up and get the answer. I think I can just do it at the end to have everything clear. But if you want, you can just do this first step and then put equal to this and solve for A. In which A would be equals to negative mu over 2 zeta. Does it make sense? In fact, yeah, sorry, this is the power negative 1. Okay. This is A. I'm going to give all the values at the end. Then I am to find, we said E. E. How can we find E? Let's see. Well, we have A. We could find H, yeah. We can find, well, sorry. E will be equals to negative 1 minus P over A. And P is equals to H squared minus over mu, sorry. And then we have H vector, which is R cross V. So we find H, we find the magnitude, we find H, we find the magnitude of H, we plug it in here, we find P, and then we plug in P in here, and we find the A from before, so we plug this one in here. Now we have to find inclination. Inclination is, let's see, the cosine of power of negative 1 of our hz component divided by our magnitude of h. Well, this is very simple. We find h right here. So we can just take our h and use it in here. We find our h both vectorial and our magnitudes. Now we can find, ran. Ran is equals to cosine of power of negative 1 of our n vector x, the x value, and then the magnitude of n. How do we find n? Well, n is equals to the k hat vector crossed with h vector. What is k? K is just a vector with 0, 0, and 1 values. So we find n, we can find the magnitude of n from there, and then we find ran. And then our algorithm of perigee, I guess, omega is equals to cosine of power negative 1 of our n vector dotted with our e vector time divided by the magnitudes of these two vectors, where we have our e vector that comes from 1 over mu times v squared minus mu over r, everything times the r vector minus r dotted with v times v vector. And then for our f, we can use our trusty formula p over 1 plus e cosine of f, where f ends up being the cosine of power negative 1 of 1 over e times p over r minus 1. Okay, so now let me clear it up and take a screenshot. I'm just going to take a screenshot of the values, sorry, the calculations. I want to take a screenshot of also the setup everything can be found on GitHub. So this is the first part. And then we have the second part here. Let me get this bigger. There we go. And then the second half, like this. And these values are all correct.